Question 1, we are dealing with 3 plus 3 over root 3 minus 1 squared. So before I go to the question, I first expanded the denominator. Root 3 minus 1 squared means multiplied by itself. Root 3 minus 1. Root 3 times root 3, property number 1, 3. Root 3 times minus 1, we get minus root 3 minus root 3 plus 1. Then 3 plus 1, we get 4 minus 2 root 3. This is our denominator now. Then you get the question and say, so we now have 3 plus root 3 over 4 minus 2 root 3. Then you multiply now the numerator by the conjugate of the denominator. This and down 4 plus 2 root 3. So we get 12 plus 6 root 3 plus 4 root 3 plus 2 by 3. Root 3 times root 3, we get 3, and then the 2 that is outside. Then down, we square 4, we get 16, minus, we square 2 root 3, so we get 4 multiplied by 3. Then we put things together, 12 plus 6, 18. 6 plus 4, 10 root 3 over, this is 12. 12, so 16 minus 12, we get 4. Then we can separate now. 18 over 4 plus 10 over 4 root 3, which is, if you divide by 2, we get 9 over 2 plus by 2, we get 5 root 3 over 2. We are done with 1. So when you multiply here, this is not conjugating. This is multiplying each piece by another piece. No more expansion. Okay? So the error that I've seen much was how to expand this one. Most of you are conjugating, just here you start conjugating. That is just expanding. Then given that A is irrational and root 2 is irrational and A is not equal to 2, show that A minus 2 over root 2 minus 1 is irrational. So you just say, okay, solution, let say X be A, this is irrational, I mean. So let A minus 2 over root 2 minus 1 be equal to X over Y. Excuse. Where Y is not 0, X, Y are integers, and X, Y are coprime. Then the target here is, because we are told that root 2 is irrational, our target is to make root 2 the subject. So you say A minus 2, you cross multiply here. A minus 2 multiplied by Y is equal to X root 2 minus 1. Then we expand, our eyes are on the right. The other side we don't care much. So I can switch them. X multiplied by root 2 minus X is equal to A minus 2 multiplied by Y. Then take this the other side. So now we have X root 2 is equal to A minus 2 multiplied by Y plus X. We're just making root 2 the subject here. So we divide by X and divide by X. So we get root 2 is equal to a minus 2 y plus x over x. When you say but root 2 we are told is irrational. What is a minus 2 y plus x over x is rational. Hence the contradiction. Yay! So a minus 2 over root 2 minus 1 is irrational. So once you are told that this is irrational, when you go to solving, after this statement here, you make that thing which has been mentioned to be irrational, you make it the subject. Once you manage to make it the subject, then you are done solving. You just write this statement here. Always. If they say root 2 is irrational, then we solve for root 2. Wherever it is, we extract it after making this statement. So here the skew is, are you able to make root 2 the subject? That's the question. Then the third one, you let negative 2.5134 bar to be equal to say x. Then what next? So you say, okay, if we multiply this whole thing by 100, what we'll be doing is just to group the like terms together. So these that are not in the bar, we put them one side. Negative 251.34 bar is equal to 100x. And then we can name this to be 1 and multiply 1 by 100. So we multiply it by 100 so that we move the numbers under the bar one step to the left. So we have negative 251.34 bar. On the right, we now have 10,000 x and call this equation 2. Then we do equation 2 minus equation 1. So we have negative 251.34 minus negative 251.34 bar. It's the same thing as 10,000 x minus 100 x, implying that we have, it's just a normal subtraction, 25,134.34 bar minus 251.34 bar. We subtract. So on the right, we get 0. And then 3 here we remain with 0, we have 13. We get 8. And then we remain with 4, we have 10. We get 8. And then we have 4, then 2. So we have minus 24883 is equal to 10,000 minus 100. We get 9,000. Oh, 9,909. 9,900. Yeah. X. Then you divide by this number. So what we have now is x is equal to negative 24883 over 9900. So the negative should always be there once it appears in the question. Then the fourth one, root of 27 plus root of 75 minus root of 108 over 1 minus root 3. So you don't rush to rationalize. You first rearrange the numerator. The question is saying the answer must be p plus q root 3. So it has given us a clue of what must be inside the root. So you get 3 and break all the numbers on the numerator by 3. So 27 divided by 3, we get 9. So you can write 27 as 9 times 3. 75 divided by 3, we get 25. So you can write 75 as 25 by 3. 108 divided by 3, we get 36. So you can write 108 as 36 by 3. So you say, okay, this is equal to, where there's 27, we write 9 by 3, plus where there's 75, we write 25 by 3, minus where there's 108, we write 36 by 3, and then divide by 1 minus root 3, giving us the root of 9, we know it is 3, root 3 remains inside. Root of 25, it is 5, 3 remains inside. The root of 86, it is 6, 3 remains inside. Over 1 minus root 3, which is equal to, since we have 3 root 3, root 3, root 3, so we can add the coefficient. So do 3 plus 5, that is 8. 8 minus 6, we get 2 root 3 over 1 minus root 3. Then we can rationalize. So we multiply by 1 plus root 3. We multiply by 1 plus root 3, which is 2 root 3 plus root 3 times root 3, we get 3. 3 times 2, we get 6. Over, we square 1, we get 1. We square root 3, we get 3. You don't square the negative, just square the root itself when you rationalize it. So now you can rearrange 6 over negative 2 plus 2 root 3 over negative 2. Then we divide, we get negative 3 minus 2 into 2, 1. So we have root 3. That's the solution there. So there are a few submissions, but at least Mangala.
There where you have, I don't know these numbers, 27 divided by 3. Is there any other way without doing that?
Like normally, okay, the other ways is you can just say you look for a number that maybe let me just say there's no other way. Though they are there, but they are a bit complicated. So this is the easiest of all the other ways. Because the idea is you must have these 3 inside here. So if I'm given 20, you know, I can break like 75. You can break 75 in so many ways. You can multiply maybe 15, I think, by some number. Is it 15, 15, 30, 15, 15, 50, 15. So you can multiply by 5. You get 75. But look, if you did this, you understand that there's none of them here is a perfect square. So we want to multiply by a number which is a perfect square number. And then we must have root 3 remaining Because if we use 5, even if 15 was to the perfect square, and then it will be like this. The question is demand that there must be 3 inside. So if we are able to extract root 15 out, we can't extract root 5 because don't know that value. So to avoid having these variations, you use the same number given in the question because they always give you a form to express your solution in. So if they say Q root 3, then use the 3 to break all the numbers. As you break 3, it will be giving you the perfect squares. As you can see here, we have 9, we have 25, we have 36. Whose square roots we know?
Okay.
Yes. So in an event where it's not given, if it's not given, then you look at the smallest root in that question. So if it's not given and we have such a question, they haven't given us p plus q root, they just say simplify. Well, because of the root 3 that is in the denominator, and we cannot extract this, we can't remove this from the root. Because even if we rationalize it, we just move from the denominator to the numerator. It means that we have to break all the other numbers using this smallest that we cannot, whose root we don't know, to break the bigger numbers so we can have some uniformity there. Any pick other question? Okay, so because this is a revision class, tomorrow we'll look at binary operations to close sets. So because we close sets after doing binary operations, you need some more questions. What I would do is, because now I'll finish marking tomorrow, I'm sure. So Monday, I will start having time. So what I would do is, we are very few, so it's easy for me to send you questions. So like I can send follow-up questions to each of you. At least every time you answer any question, I learn how you learn. So it becomes easy for me to fix any error that I notice on your working. So I can send follow-up questions so that you can build up on that, so that we won't spend much time on sets. I'll just remain with individuals that still need me on sets, of course, at our own free times away from the class. So that after we do binary tomorrow, then on Monday, is it Monday or Tuesday, we start doing functions, then we'll be moving in that same pattern. So that I end here, I have another class with the engineering guys. And then that's any journey. Good night.